Welcome, ladies and gentlemen, to the Forum of Hydrogen and Fuel Cell Europe here on Hannover Messe 2023. And now something completely different. We're coming now to the Norwegian Industry Partners elevator pitching session. And I'm very happy to announce to you that yesterday we had a German-Norwegian hydrogen seminar in the forum, and we presented and discussed the ambition of Norwegian and German politics developing a bilateral hydrogen alliance on hydrogen export and import and Norwegian's industry's contributions. We were discussing that here in two different panels, and we wanted to show you what the ambition are of the Norwegian industry. So we want to focus on the competences and activities of the industry exhibitors from the Norwegian pavilion, which you can see right opposite of us. To give you an impression of the variety and the expertise of our Norwegian exhibitors, we decided to present to you 9 of these companies in an elevator pitch. Everyone has only 3 minutes and maybe some seconds. I'm not that sharp today, but in general, only 3 minutes and to present themselves. And all of them are inviting you to join the networking and social event at Norwegian Pavilion right after this session, so stay here. And right after that, there's going to be 1 or 2 aquavit for every one of us, and maybe a beer as well. So I really can advise you to stay here, listen to the presentations. It's going to be an elevator pitch, so it's just 3 minutes, and that's all, and then I will interfere. So I said enough. Let's start the elevator pitch with Arne Nikander, Project Director, powered by Telemark, Skagerrak Energy, and he will talk about the regional approach to develop schemes for the provision and use of blue and green hydrogen. Arne, where are you? Here they are. Okay, enter the stage. Good luck. And this time starts now.
Thank you, Uli. Guten Nachmittag, liebe Freunde. Geht's gut? Yeah. Powered by Telemark is an industrial and tech cluster with more than 125 members. And we are situated in Porsgrunn at Herøya. Herøya is the hydrogen city of Norway. We have a lot of very important companies, internationally important too. You can see here Eramet, Yara, Ineos, Innovin, Vianode, Nel og REC. And we are cooperating with all the research and development companies too. And that is the main focus today. We are just into the SIVA system with the catapult center and catapult node system. And we will focus on the large-scale test facility for hydrogen and ammonia, which we are very good at this moment with Upstart, with a big electrolyzer from Hydrogen Pro, the world's largest one, 5 megawatts. And they are testing right now. And we will be developing this over a period of 18 months to be an international center for testing of the large-scale hydrogen. We have the water, we have the power, and we have all what you need for supply chain products. Together with the sustainable energy, which are situated in the west part of Norway, at Stord, close to Bergen, we now take part in a big cooperation all over Norway to identify and develop and open up testing facilities for other companies. So we are providing a full scoop all over Norway to give other companies the shorter road from ideas to market. That is the main issue. So I hope we are on time.
We are indeed, Arne. Very good.
Skagerrak Energy, Herøya Industripark, and Equinor, together with the SIVA system and sustainable energy.
And it's
Thank
always
you.
hard to break the ice, and you did it perfectly, Arne. Thank you very much for that. Please give him a warm applause. Thank you, Arne. So we have the next presentation coming from Marie Fløystad Dahl. She's a consultant at Greater 4H, and speaking of the String region and the String mega region consisting of local and regional governments in Germany, Denmark, Sweden and Norway together with 6 private companies are planning a connected network of hydrogen fueling stations from Hamburg to Oslo. That's quite exciting. So we will hear about the Greater 4H in the hydrogen corridor, enabling long-range, heavy-duty road transport from Hamburg to Oslo with zero emission. Marie, I'm awaiting your presentation. Here you go. You're welcome.
Hello. Okay. Thank you very much for the introduction. I am, as you said, here to represent the project Greater 4H. And my name is Marie Fløystad Dahl, and I work for the organization String. String is a political member organization with public entities as members. And String works for green cross-border infrastructure in Norway, Sweden, Denmark, and Germany. And one of the newest, greatest initiatives that we have in String is Greater 4H, which is, as was said in the introduction, is a cross-border hydrogen refueling corridor connecting Hamburg and Oslo. So, what is actually Greater 4H? Greater 4H consists of 14 hydrogen refueling stations along the 10T ScanMed corridor. They are placed, as you can see here, symbolized with the dots, and there will be 150 kilometers apart of all the stations. We have been so lucky to receive 30% CEF funding, which is an EU program. And the official project start was October 1st last year, and it is now a 3-year project. So all the stations will be implemented within 2025, which means that it's really a project that is happening right now, which is very important for the transport sector, especially the HGV sector. So this is a corridor for refueling green hydrogen for heavy-duty vehicles. And the partners that I would like to show you, yes. So the project partners of the project is Everfuel, Hynion, and GP Joule. So Everfuel are implementing some of the stations in Denmark and Sweden and Germany, and then Hynion in Norway and Sweden, and GP Joule in Germany. So we are very lucky that these 3 competing companies are actually going together to build this hydrogen corridor. This is also a private-public project, which is, as you may have heard all the politicians talking about here at the fair, is really the key to success. So, and this is a practical example of exactly that. So, we are really looking forward to implement these stations and accelerate the implementation of green hydrogen in the String region. And at the same time, we have a vision to maybe eventually extend the corridor even more, maybe to Berlin or Brussels, or maybe here to Hanover. So thank you very much, everyone.
Thank you very much, Marie. Just stay for a second, please. Because I have a little question. The good thing about this project is one of these partners I know, GP Joule, because I know they want to buy 5,000 heavy-duty trucks. So these refueling stations will have some income also, which is very important to keep that alive.
Yeah. That is really much our challenge as well, because we really need the heavy-duty vehicles. We don't want our stations to be standing there without anyone using them. So we're really lucky to be working with GPJoule with this.
Indeed, I think so too. And I don't only like your project, the string project, but I also like the color of your suit.
Thank
It's
you
wonderful.
very much.
Thank you very much, Marie. Thanks once again. So next presentation will be about the project development for the provision of green hydrogen to its end use. And I would like to welcome the Senior Vice President Sales of Gen2 Energy AS, Andreas Ecker. There he comes.
Hello. Hello, everyone. Thank you very much for showing up for this pitching session. My name is Andreas Ecker. As introduced, I'm going to tell you over the next 3.5 minutes about Gen2 Energy and what we're all about. 3 key messages. Gen2 Energy has a supply chain for green hydrogen. Number 2, we do have a product portfolio of multiple projects, so it's not only one project. We are here for the long run. And thirdly, we have our first project, which we want to have on stream already in 2026. So those are the 3 things I'll tell you about. Next slide. Or am I doing it myself?
Use the green button, yes.
Here we go. All right. Let me first tell you about our supply chain. We start by using renewable green energy from Norway, either from wind or hydropower. This secures that we meet any RED 2, 3 requirements. So it's a totally green hydrogen that we are producing. Secondly, we do believe in large-scale production. So our plants, this one is going to be 100 megawatt, large scale, and since we do get energy off the grid, we are able to produce 24/7. So we don't have the issue of load factors. We have a competitive advantage when it comes to being able to produce stably throughout the clock. Then further on, we are working with partners, both on the shipping side and the container sides, to develop the supply chain as such. We are, so the vessels are developed tailor-made for bringing the products into the hubs. And finally, the containers needs to be rotated, so the same ship will actually bring the products, the containers back to Norway. As you see on the map, we are looking at markets in the UK, in the Netherlands, and or in Germany. Those are the key hubs that we are currently trying to develop this project or our projects together with. Finally, you see that there are multiple dots out of Norway. As mentioned, we have 5 different projects, adding up to approximately 1 gigawatt capacity of power. So we do have new projects coming online. This is the Nesbruket facility that we are developing as we speak. It's a 100 megawatt electrolyzer facility. Will produce more than 13,000 tons per year of green hydrogen. We are using conventional containers. They're already on the road today. We are using 2 purpose-built ships, and the FEED study is ongoing. So if everything goes as we hope, we will be in production in 2026. That's it. Thank you very much for listening. If you want to discuss more, if you want to hear more about what we do, please come to the Norwegian stand. And before I leave you, we have a supply chain, we have a project portfolio, and our first project should be online in 2026. Thank you for listening.
Thank you, Andreas. Thank you very much. Just stay with me 1 second. 1 second, Andreas, because I would like to know, I've seen you want to export green hydrogen to Scotland. I know they're producing green hydrogen themselves and want to export it to Germany. So bring it all to Germany. Okay, you can have it. All right. And the second thing I would like to ask, I learned about Gen2 Energy, Gen2 Energy, that you are also using the heat for fish farming. I found that a very interesting idea. The heat of the electrolyzers.
Well, it's one of the potential uses, and indeed, we are a company that is based on circular economy. So it's one of the ideas that we're really trying to develop.
I think it's always very important to keep that also in mind, that from electrolyzers not only coming hydrogen out, but also the heat, and we should use it, indeed. Thank you once again, Andreas. Here's applause once again. We'll now hear about driving green transition by the developing and operating of green hydrogen infrastructure aimed primarily towards heavy-duty transport and maritime customer segments. We will hear the business development green hydrogen at Norwegian Hydrogen, Christopher Grete. There he is. Christopher, go ahead.
Yes, thank you. My name is Christopher Grete. I'm a business developer for Norwegian Hydrogen. So I wanted to start a bit on a brief story and the background about the company. So this is the beautiful Geirangerfjord. This is where it all started. A UNESCO World Heritage fjord set to be emission-free. A small village called Hellesylt with a large surplus of power and the desire to contribute to a greener world for all of us. Norwegian Hydrogen drives the green transition through the development and operation of hydrogen infrastructure and aim primarily towards heavy-duty transport and maritime customer segments. We will provide infrastructure, including production facilities, distribution systems, and a wide network of fueling and bunkering stations. Our purpose is to enable zero emissions for our customers.
Use the green button, yes.
Yes, so this is our owners, industrial owners, and how important they are. They are committed, engaged, and have industry experience and a valuable network. We have the Flak Group and Mitsui as large investors, and we have Hexagon Purus as a global leader and in key technologies that is needed for zero-emission mobility. We have Tafjord as a hydropower producer, and we have Hofset, which is one of the largest processors and exporters of salmon and trout in Norway. Yes, this is where we're located at the moment. We're all over the Nordics and aim to be the leading hydrogen refueling company in the Nordics. So from the Berlevåg up top to Ålesund, which is our headquarters, we're in Denmark, Sweden, and also Finland. We have 3 main business segments, and we are building a complete value chain for green hydrogen. We will be owner and operator for production hubs. The first one is the mentioned Geirangerfjord and the Hellesylt hydrogen hub. Local production for local usage and refueling or bunkering for trucks and maritime application. For industrial application, we do look at several opportunities. And as you can see on the picture in the middle, we will produce hydrogen directly from all green energy sources. And in this example, it's from wind power. And for refueling, we have recently launched a new company for heavy-duty trucks refueling in the Nordics. It's called, we'll see, Virion. From day one, refueling have been an important part of the Norwegian hydrogen strategy. To reach our high ambitions, we have learned that we need a dedicated team to focus on refueling only. Earlier this year, we therefore launched this company, Virion, with the aim of becoming the leading hydrogen refueler for heavy-duty trucks in the Nordics. Virion is well on its way, with stations planned both in Finland, Sweden, Denmark, and Norway. The first station will open later this year, and hopefully with many more to come.
Thank you very much, Christopher.
I had one last one, but
okay. Okay, go ahead.
I'm obviously out of time. It is about our cooperation with Provaris. So we have seen that there is a need for export to Europe, and hopefully we can utilize Provaris' GH2 carriers and storage solutions to this and export to Europe.
Now, very good. Christopher, thank you very much. It started like a fairy
Thank you.
tale and ended like a thriller, really. Thank you very much for that. All right. And you already introduced the next speaker, didn't you? Provaris, it will be. And we will hear Per Rødt, the CTO of Provaris Norway AS, and he will talk about H2 Neo, developing integrated green hydrogen projects for export to regional markets through the simplicity and efficiency of compressed hydrogen transport by ship. Per, it's your turn.
Thank you. I'm going to have to make this very thrilling now, right? So this is going to be a challenge in 3 minutes. But yeah, so Provaris Norway AS is the European office of Provaris Energy. Provaris Energy is an Australian listed company who spent the last couple of decades focusing on compression and gases. And we started in 2019 to focus on hydrogen, going from compressed natural gas into what we could do in order to prepare for the future. So we started essentially with the development of cargo containment systems and shipping solutions using compressed hydrogen up to 250 bar. From there, we sort of migrated along the value chain up to more the upstream. We have our own project to produce 100,000 tons of hydrogen in Australia that's under development. We have the collaboration with the Norwegian Hydrogen AS that Christopher just mentioned. So we're looking at finding ways to utilize as much existing technology, such as compression, etc., to bring hydrogen to the market at a very cost-effective solution. So the 3 pillars that we have is, the patent and the development of the cargo containment system. We have moved into the production of hydrogen, learned the value chain, and we're able to go out and offer a wide range of customer shipping solutions and storage solutions. So the value chain, as shown, we got the shipping. Today we also had the PR on our approval for a storage barge solution. We can now essentially offer storage of floating storage solution of hydrogen, 300 to 600 bar. We got the AIP from Klaus on that, and we're looking forward to progress that along the way here fairly quickly. So why compression? I think that's what we want to try and show in this one. The transportation and delivery of hydrogen is very different than what you have had with natural gas. The energy source is not coming 24/7, 365 days a year out of a well into a steady state cold box to liquefy, or converting it into another project such as ammonia. The bottom graph there shows, a typical, that's a 3 gigawatt renewable energy profile, wind and solar. It goes up and down. One day you can produce 11 tons, another day you can produce 145 tons. So how do you manage to even out the peaks and troughs? You need batteries, lots of batteries, you need hydrogen storage, and what that does is essentially just add capital to your project. So you need to consider the whole value chain, as our opinion, when you look at the export and import of hydrogen. So for a number of the other vectors to even out, create that base power, all you do is increase the cost of the molecules. So compression, you might need more assets to do the shipping, but when you look at the economics of it in a regional scale, then compression has a lot of benefits and can deliver it effectively to customers. And Norway to Germany, perfect case. 1,000 nautical miles, you can cover the cheaper regions of electricity in Norway, you can bring it down at very affordable rates, the way we see it at the moment. So Christopher mentioned our collaboration with Norwegian Hydrogen. We've been looking at a number of opportunities from the Nordics. Will come out publicly soon as an opportunity to essentially bring 45,000 tons with possibility to scale up from Norway into Netherlands or Germany. We'll try Germany, of course, only. But that's using the H2 Neo as shown here. We'll have one barge allowing you to have continuous production will be flexible with the grid providers, will take energy or electricity when demand is low from other consumers. We'll scale down because we can when there's high demand and we need to export electricity to elsewhere. And we'll take it down, and we are very keen to talk to any off-takers who might be in the house. So thank you.
Thank you very much, Per. That was a presentation in 3 minutes, I would say, indeed. Not really a pitch, but really great, indeed. You did it. Thank you very much. So we are coming now to the next exhibitor at the Norwegian Pavilion, and he's customer advisor at Billington Process Technology AS. It's Simon Martinsen, and he will speak about advanced simulations de-risking hydrogen systems. Here he comes. Simon, go ahead.
Hello. So what I will
Oh, you better use the microphone, then we can hear you better.
That's usually a good idea. So what I will talk about is advanced simulations to de-risk and optimize any green energy process. So what are the challenges that we see today when it comes to green energy? Well, first and foremost, we're going to produce hydrogen at a scale never done before. And that also comes with a certain amount of risk when you start to scale things up. We are talking about varying power sources like wind power, onshore and offshore, and also solar power, and this varies throughout the day. And how will your process plant handle these changes? A lot of people just think about the stack highlighted in yellow there, but in reality, you have a lot of utility systems connected to any hydrogen plant, and that is what you see around there. So everything except what is highlighted in yellow is utility systems, pumps, heat exchangers, coolers and such. And this risks also makes a risk when it comes to return of investments. And what we have seen, we are doing process simulations. We have done that for decades in oil and gas. But there are certain gaps when it comes to looking at the dynamics when it comes to green energy systems, but we have now closed those gaps, basically de-risking processes. But when you look at hydrogen as a standalone thing, that's one thing. But it gets even more complex when you look at power-to-X systems. Hydrogen combined with CO2 to create methanol or ammonia, or e-fuels. You can use methanol or ammonia in the shipping industry. We are working on electric fuel projects, basically taking CO2 from factories, combining that with green hydrogen, making carbon-neutral synthetic aviation fuels. But the complexity increases the more things you are putting into the systems. So what we basically do is that we help companies to de-risk any green energy process. Taking down the risk will, of course, also bring down the costs. This is of great importance these days. If you're really going to make an energy transition, you will need to bring down the cost. We do this with domain knowledge, but we also have unique simulation capabilities. I have a live model running over there. I can show it to you. But we also have a life cycle perspective on this. We do optimized design, automatic simulations that run through the night. We then make operator trainers. You can train your operators way before you actually have a live plant. And we put this into digital twins, which you can see there. It's a physics-based digital twin. The orange trend there is a physics-based simulated value. The blue one is the sensor value. And as you can see, the sensor value fails 50% of the time. So it's about de-risking and optimizing everything for green energy processes. So thank you.
Thank you very much, Simon. And I'm really impressed about what's going on in Norway and what different fields you are covering. So also de-risking is a big topic indeed, and you made it very clear that is in incentive assessment of Norwegian industry. Thank you very much once again, Simon. We are now coming to the design and supply of large-scale hydrogen high-pressure alkaline electrolyzers, and we will hear the CCO of Hydrogen Pro ASA, Eric Christian Bolstad. And there he comes. Eric, it's your word. You're welcome. I'll take your microphone. So that's fine. Perfect.
Hello and welcome to the session we have here. Welcome to the audience. Welcome to dear hydrogen enthusiasts. I hope, are you tired? Are you ready for one more go? We represent the development, the production, manufacturing of large-scale hydrogen stacks and balance of stacks, basically equipment, so large industries can produce cost-efficient hydrogen for their use. We had our commercial breakthrough last year with a 220 megawatt order for US, so we are actually, as we speak today, producing for that order. The plant is under construction, will be the biggest plant in US for hydrogen. So this is happening now. So it's not a PowerPoint, it's happening now. And we base this on our core technology, being high pressure alkaline. And I don't want to read everything, but we think big, we think modularity, we think scalability, how to develop solution cost efficient with a focus on energy consumption. That's why we spend a lot of time and efforts on further optimizing the performance of the equipment so we can help the industry to drive down the cost, to support the energy transition. We have manufacturing capacity in Asia today, 300 megawatt, but that's far too little, so we are already planning for more than a gigawatt expansion, and that will happen in US, it will happen in Europe, and in Asia. Because being global is truly being local. We need to be close to the projects. And again, emphasizing, you see the modularity in the center. So in the factory is 50 megawatt or 500, it's the same modules, it's just the numbers that are different. And in this way, we can support all these type of demanding industries, having a demand for a high volume, steady volume, and at the same time, being totally flexible towards the renewable energy they are going to use. So it means we have to ramp up and down immediately when it takes. And the technology is designed in such a way that we are able to do so within a second from 0 to 100 and down again, making us very flexible towards renewable energy. Today we are producing 1 cell stack a week of the world's biggest cell stack, 5.5 megawatt, close to 100 kilo production per hour each unit. And we will keep on ramping that one so we can feed these industries so they can meet their targets. Example in the end, this is the project in the US where they will use hydrogen as a battery. They will take curtailed, so-called spare electrical renewable capacity when available, produce hydrogen, store it in salt domes, massive volumes, and then they will use the hydrogen at need to produce electricity back to the network when needed, but also support industries, mobility, transportation. So this will feed LA and the Southern California with energy. And this plant starts commissioning in 24. So it's happening now. Very important. We need future, we need developments, we need new things, but we also need to provide solutions as we speak. 220 megawatt. I'd like to take the opportunity to thank you. I probably spent less time than I had, first time of my life, people knowing me. But I'd like to welcome you to our booth, Look to Norway. We are right behind you if you want to talk more about electrolyzers and the next generation of large-scale production. Thank you.
Thank you very much. This is your applause. And let's use the spare time, Eric. Let's use the spare time. So tell me a little bit, what's the 220 megawatt project in the United States? Was that before or after the Inflation Reduction Act?
It was initiated and actually financed and committed before the IRA was implemented. But it will also benefit from the IRA, but it's a sustainable project that makes sense because you will balance the energy balance in the region of Southern California in particular. It is located in Utah, where you have massive wind, you have PV. So it's all about to capitalize on the spare, how to store it. Batteries cannot do the job, hydrogen can.
So the IRA was a very nice incentive for you in the end, yeah?
Yeah, and we see now there's an explosion of projects in US, especially related to derivatives like synthetic fuels, popping up projects all over, and I think IRA has in a way, been initiating this because now they have a more longer lifetime in order to capitalize or calculate the projects.
If I look around here on this group exhibit here in Hanover, I see a lot of PEM electrolyzers actually. Very few alkaline. Tell me a little bit what are the advantages of alkaline?
No, it's of course it's about production costs. It's about long lifetime between maintenance. It's about large scale. When you do 500 a gigawatt and you have a PEM electrolyzer less than a megawatt, you get an enormous amount of units. So in this way you get the more cost efficient, but it's also about adapting the technology in order to meet the future demand. But that said, I believe there is space for everyone, and there is no technology that covers everything. So we have to be, let's say, loyal, and we have to see, we focus on our niche, and we see there are different technologies that are better for other niches.
Eric, there's space for everyone, and alkaline electrolyzers need a lot of space, by the way. But anyway, that's another topic. Eric, see you later. Thank you once again. This is your applause. So we have the next presentation here from Paul Brothen. He's CEO of Lattice International AS. He will talk about unique scalable containment solutions for hydrogen. Paul, it's your turn.
Thank you very much. Good afternoon, ladies and gentlemen. Pleasure to be here, back in the country where I studied a number of years ago. I'm going to talk about our scalable containment solutions. And this is a world first new concept, quite innovative concept that is about absorbing pressure in cryogenic gases in a grid structure called lattice structure. This means that you can actually scale a pressure vessel to any size and in any shape that you like. So we are heavily involved in LNG, and the CO2 carbon capture and storage market is coming. This technology can also be used for liquefied hydrogen. And so we are obviously in that space working with projects between Australia and Asia. And we have an approval in principle from Lloyd's for a 50,000 cubic meter vessel that can carry that load in 11 days to Korea from Australia. And you can see the structure. The point here is that if you absorb pressure inside that grid, you can scale the shell of the tank to any size and shape you like without increasing the thickness. So that means you can have a much larger tank than any cylindrical tank. So if you apply this to a truck, ISO container comparison, we can carry 40% more gas on the same space. So somebody mentioning 5,000 trucks earlier, you can do the math on that if you carry that every day with 40% more. So the value proposition should be pretty clear. Instead of a lot of infrastructure, we have basically one. And therefore you can make significant savings because you have a completely different space utilization. It can be scaled up to at least 25,000 cubics. So this makes a tremendous impact on large-scale intercontinental freight of liquefied hydrogen. Obviously, the cost reduction will then per unit is significant. And this whole point about what is going to be the future solution, what is going to be the energy carrier, I think we have showed in our project in Australia that we are able to compete with fossil diesel in the Korean market with green hydrogen produced in Australia. Because the transportation is the cost driver in all these projects. And as you can guess, we are involved in several projects between Europe, Middle East, and Australia for large-scale transportation of energy and CO2, for that matter, using this principle and receiving a lot of attention also on the political level. Because we think that this solution is part of the solution, to tip the scales, to show that liquid state it might be having a great future provided you can transport intercontinentally. Thank you very much.
Paul, thank you very much. This is your applause. And just stay for a second, please, to give you one question, because this is for vessels, you know, and you will transport liquefied hydrogen. This will be cooled down by 253 minus Celsius. You will always have a boil off. Do you use this boil off for propulsion of the vessel?
Yes.
Thank you for that. Very good. Congratulations. So once again, applause for Paul. At the end, we come to another important topic, which is consultancy. To expert consultants in renewables, hydrogen, and maritime, Thema and Kongstein are making joint efforts to support your investment and business decision with market analysis, strategy, and technical advice. Let's listen to Robert Seguin from Thema Consulting Group and Eric Peach from Kongstein. They will talk about consulting in renewables, hydrogen, and maritime to support your investment and business decision with market analysis, strategy, and technical advice. Here are the two gentlemen.
Thank you very much. Yes, I represent Kongstein. Kongstein is an independent maritime advisory. We have a clear mission that is enable the green shift. We are specialized in offshore wind project management with experience for the last 15 years. So the original projects that were initiated in Germany, and in hydrogen, maritime hydrogen transportation, handling, storage, which we have done for our clients for the last 5 years. We are located a Norwegian company, offices in Norway, Germany, the Netherlands, and in Australia. So recently opened it up, and our clients typically are project developers in offshore wind, the supply chain that is relevant to provide these large-scale maritime renewable projects, and some of the grid operators that is actually transporting and transmitting the energy. And we work very closely together with Thema in consulting and bringing companies into the renewable market. So we also advise new market entrants on where they can they have the best fit, and of course also how it's been calculated and the number crunching, and that's now coming to Robert, to Thema.
Thank you very much, Eric. If you could just click on the slide once. Thank you. My name is Robert Seguin. I represent also a consultancy company, as Eric said. Come from Thema Consulting. We are Oslo-based, but have also an office in Berlin. So just as Kongstein, we already represent the collaboration between the two countries. We come originally from the power market side, and we cover the non-technical aspects of hydrogen. So we have basically 3 different business units. One is classical strategic consulting, one is socioeconomic analysis, and one is market analysis and market modeling. So I said we come from the power market side, so we have our own proprietary power market model that we can use in order to analyze different power markets all over Europe, not just in Norway and Germany. And we use this model in order to give in-depth market analysis for power assets, but also for hydrogen assets. We use this insight to do studies and reports and bespoke analyses and projects together with our clients. And our clients would typically be business development or strategy units in the companies we work with, but also ministries, for example, or regulators. And as I said, we come from the power market side, and we do a lot of looking into the future, how the power market is going to develop. And undoubtedly, hydrogen is going to be one of the basic puzzle pieces in the future. So we've had hydrogen on our screen for quite some time, and I've done analyses around hydrogen for quite some time. So we've built up different competency areas that we can help our clients with. We can do market analysis, as I said. We can look at hydrogen as a flexibility source, which was mentioned before. How much value is actually in this flexibility proposition, both on the demand side and on the production side? We can look into business development. We follow closely policy and regulation, especially when it comes to market design questions for the power market, but also prospectively in a hydrogen market. And we've done projects together with our partners on the application side in the transport and industry sectors. So if I can ask you, Eric, to click one more. So the reason why we choose stand here is we cover different parts of the value chain, and together we've partnered up to feel that we can give you the whole package and give you a more fact-based consultancy offer that drives you from strategic questions through market analysis to the technical side then, and hope that you will come join us on this.
Thank you very much, gentlemen, and hope to join us, not only here, and join us in clapping your hands, of course, that's now. And also join us to the Norwegian Pavilion. I would like to thank you all for sticking to the 3 minutes that you only had in this pitching. We are just on time at the end, and I would like to see you all over there at the Norwegian Pavilion to join our social event and have some nice snacks and maybe an aquavit or two, so you will be provided there, also with some nice beer. So join us, have a nice evening, enjoy it, and this was the Norwegian pitching element here on the Hydrogen and Fuel Cells Europe. Thank you very much, gentlemen, and see you later.